This video is going to look at what Avogadro's number is and learn how to use Avogadro's number to convert between moles and particles. So to begin with, Avogadro's number is 6.02 times 10 to the 23rd, and that's how many particles are in 1 mole of a substance. Those particles could be atoms, molecules, ions, or formula units in the case of ionic compounds. As a conversion factor, Avogadro's number would look like the following: either 6.02 times 10 to the 23rd particles over 1 mole, or you can flip it and have 1 mole over 6.02 times 10 to the 23rd particles. Now let's look at how we can use Avogadro's number to convert between moles and atoms. And here's an example problem. How many atoms are in 3.5 moles of silver? So to solve this problem, we will start with the amount that we're given, which is 3.5 moles of silver. And we're converting to atoms, so we will use Avogadro's number, put 1 mole of silver on the bottom. Avogadro's number, 6.02 times 10 to the 23rd atoms of silver on top. Moles of silver cancel. Our units are left with atoms of silver, which is what we are looking for. Now we can simply plug this into the calculator. I want to say a couple of things or just kind of show you how you can plug this into the calculator. So I'm going to get out of PowerPoint for a second and launch the computer's scientific calculator. And so we're going to plug this into the calculator so I can show you how to enter numbers that are in scientific notation in a calculator. Start by entering 3.5 times and then our 6.02 times 10 to the 23rd. When you are entering numbers that are in scientific notation into your calculator, you need to use the exponential notation in your calculator. And that's either going to be an EE key or an EXP key usually. And so for this calculator, we would do 6.02, and then this EXP key is the equivalent of times 10. So I'm not going to do times 10 and then put in my exponent. I just hit 6.02, the EXP key, or it could be an EE key. Both of those are going to do the same thing. And then you simply enter your exponent, which in this case is 23. Hit enter. I get a really large number. On my computer's calculator, I can click that little button and it'll put it back into scientific notation. So the answer to this problem is 2.107 times 10 to the 24th power. We would round this to 2 significant figures because 3.5 has 2 significant figures. So I can go back into my PowerPoint and we'll enter that in there. So my answer to this problem is 2.1 times 10 to the 24th atoms of silver. Okay, let's look at another problem. How many moles of carbon would you have if you had 7.4 times 10 to the 25th atoms of carbon? So we want to convert from atoms of carbon to moles. We'll use Avogadro's number as a conversion factor. So as always, we're going to start with the amount that we're given, which is in this case 7.4 times 10 to the 25th atoms of carbon. It's always important to write down your units and your substance so you can make sure things are set up properly to cancel. Since I have atoms of carbon on the top, I'll use Avogadro's number on the bottom, 6.02 times 10 to the 23rd atoms of carbon, and that is 1 mole of carbon. So remember to use your EXP or EE key when you are entering those numbers in the calculator. Do not do times 10. It will mess it up and you will not get the right answer. But you plug that into your calculator, 7.4 times 10 to the 25th divided by 6.02 times 10 to the 23rd. And we would round this to two significant figures. So we get 120 moles of carbon. Okay, let's look at one last example. This question says, how many atoms of carbon are in 6.8 moles of vitamin C? And it gives you the formula for vitamin C, which is C6H8O6. So this one's a little bit different. We are going to have one additional step because we're wanting to solve for atoms of carbon from vitamin C. And for every one molecule of vitamin C, there are 6 atoms of carbon, or 6 atoms of carbon in it because it has a subscript of 6 for the carbon. So we're going to have to add one more step in this, but like before, we're going to start with what we're given, which is 6.8 moles of vitamin C. Since we're just looking for atoms of carbon in the end, I'm going to convert from vitamin C to just moles of carbon. And so for every 1 mole of vitamin C, there are 6 moles of carbon. Those cancel. And now we can use Avogadro's number to convert from moles of carbon to atoms of carbon. So 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. Plug that into our calculator, 6.8 times 6.02 times 10 to the 23rd, and we get 2.5, rounding to two significant figures, times 10 to the 25th atoms of carbon. So those are just a few examples to show you how you can use Avogadro's number to convert between moles and atoms, and also to show you how you can use the exponential notation in your calculator so that you enter those numbers that are in scientific notation correctly in your calculator.